Hi students, today we will discuss the structure hazard in the pipelining. It is a one type of the hazard which will be there in the pipelining. As in the previous classes of the pipelining, related to the pipelining topic, we have already discussed what is the pipelining, what is the need of the pipelining, and what is the difference between the pipeline structure or data path and unpipelined data path. After that, we have discussed what are the different problems, what are the different hurdles, and why those hurdles will occur, and what are the different types of the hurdles. As we have already discussed that the three types of hurdles, which are also known as the hazards in technical terms, are structural hazard, data hazard, and control hazard. We have also discussed in the previous classes how can we evaluate the performance of a pipeline structure with and without hazard or with and without stall. So today we will discuss the detail of structural hazard which is there in the pipelining. So when a machine is pipelined, the overlapped execution of the instruction requires the pipelining of the function unit and duplication of resources to allow the all possible combination of the instructions in the pipelining. If some combination of the instructions cannot be accommodated because of the conflict of the resources, the machine is said to be have a structural hazard. So whatsoever the hurdles will occur due to the sharing of the conflict of the resources or due to the sharing of one resource, that is called the structural hazard. So when two instructions trying to use the same resource at the same time, so whatsoever the hurdle which will occur is called the structural hazard. The most common instance of the structural hazard arise when some functional unit is not fully pipelined. As to convert an unpiped line, each and every unit of unpiped line will have to be synchronized with the pipelined structure. But due to any reason, if all the units will not be completely synchronized with the pipeline structure, then a sequence of instructions using that unpipelined unit cannot proceed at the rate of 1 per clock cycle. So another common way that the structural hazard appear when some resources had not been duplicated enough to allow all the combinations of the instructions in the pipeline to execute. For example, a machine may have only one register file write port, but under certain circumstances, if the pipeline might want to perform two write operations in the same clock cycle, then this will generate a structural hazard. So in other words, we can say that whenever two different instructions want to share or want to use the same source, then whatsoever the conflict of resources will there, that will be called as the structural hazard. Now we will discuss the structural hazard with one example. Some pipeline machines have shared a single memory for data memory and for instruction memory. So as a result, when an instruction contains a data memory reference, it will have a conflict with the instruction reference for a later instruction. So we will try to understand with these two figures. So now in this particular, now we will take example by considering a machine which is having a single memory unit, and that single memory unit will have to be used for instruction fetching and at the same time for the data transfer. And if two different instructions try to access this single memory unit at the same time, then whatsoever the problem which will occur over there, that is called the structural hazard. Okay, so now we will try to understand what is the structural hazard in detail with the help of this example. Let's suppose we are having a program, and say the program is having the different instructions. Instruction I is the first instruction, I plus 1 is the second, I plus 2 is the third, I plus 3 is the fourth, and I plus 4 is the fifth instruction. And on this side, let's suppose the different clock numbers are there, and we will make one assumption that the first instruction of this program is, say, the load instruction. And then as per the sequence of execution of this program in the pipeline structure, it will be in the first clock cycle, the first instruction, which is the load instruction, will be fetched from the memory. During the second clock cycle, the first instruction, whatsoever the opcode was fetched from the memory during the first machine cycle or during the first clock cycle, will be decoded, and at the same time the second instruction I+1 will be fetched from the memory. In the third clock cycle, the first instruction will be executed by the executed unit of the pipeline structure after the decoding, and the second instruction will be decoded once it will be fetched in the second cycle. And at the same time, the third instruction, which is I+2, will be fetched as per its routine process or routine sequence. What will happen in the fourth cycle? In the fourth cycle, whatsoever the first instruction which was executed in the third state, and as per the need of the instruction, which is the load instruction, the instruction will have to load the data from the memory, and at the same time the fourth instruction will have to be fetched, and again the fetching of the opcode for the fourth instruction will also be from the memory. Now if we will take this example, let's suppose the memory unit which is interfaced with this machine is only one unit, and processor can access one word from that particular memory at one time. But as per the need of the instruction, what is the need? The need of the instruction is to load the data from the memory for the first instruction, and at the same time opcode will have to be fetched from the memory for the fourth instruction. And again, what is the limitation? The limitation of this particular machine is it is having only one memory unit, and which is interfaced with only one set of address, data and control line with the machine. So as per the limitation of the machine, which can work in unpipeline structure, but it cannot work with the pipeline structure, because in this particular cycle, for this particular case, the data path of the processor will want to access the two different memory for two different instructions, but for one cycle. So whatsoever the problem that will occur during that point of time will be called the structural hazard, because processor can access the data from the one unit of memory for one instruction only, but here there is a need to access the data for two different instructions within the same cycle. So whatsoever the problem which will occur over here, that will be called as structural hazard. So what is the solution of this? How can we resolve it? To resolve this structural hazard, we will have to introduce a stall in the pipeline of one clock cycle. So this particular one clock cycle stall, which is just a delay in during that particular time period, the whatsoever the data path will be responsible to fetch the opcode from the memory for the I+3 instruction will not do anything. It will gives the delay, because during this fourth cycle the first instruction is already accessing the memory, and due to the limitation or due to the structural hazard, another stage of the pipeline cannot access the memory because there is only one memory. So this will be a one stall which will be introduced over here, and the fetching of the I+3 instruction will be delayed by one clock cycle. Actually, the expected fetching for I+3 instruction was in the clock cycle number 4, but due to the structural hazard, but due to this stall, the fetching of the I+3 instruction is delayed by one clock cycle. So instruction of the opcode of the I+3 will be fetched in the 5th clock cycle instead of 4th clock cycle. So once it will be fetched in this clock cycle, and again we will have to make one assumption. If the second instruction will be load, then again one more hazard will be there. Again in the fifth cycle as well, this opcode cannot be fetched in that particular case if the second instruction will also be the load instruction in which the memory access will be there. If we will assume the circumstances, if we will assume the program is written in such a way that only the first instruction is going to access the memory in the fourth cycle of the instruction cycle of that particular instruction, but if and no other instruction will access the memory in the its fourth cycle. So with this assumption, in the fifth clock cycle, the second instruction will not read or will not access the memory, as we have already assumed that the second instruction is not going to load or store from or to the memory. So this particular stage of the I+1 instruction is not going to do anything, is not going to access the memory. So that is why the instruction fetching is possible in this particular case. But if the second instruction will also be loaded, let's suppose the second instruction is also a load instruction, then again the same situation will occur in the fifth cycle as well. Then again this instruction fetching will again be delayed by one more stall. Okay, so we will assume that only one stall will be introduced if by considering or by assuming that only one instruction is belong to the load instruction and rest instructions are not load instructions, or at least rest of the instructions are not going to read or write the data during the memory access cycle of its own instruction. Okay, so if we look at what will happen to the execution of the program, then we can see that the first instruction will be executed after the fifth cycle, the second instruction will be executed after the sixth cycle, the third instruction will be executed after the seventh cycle. But due to the structural hazard, but due to this stall, but due to this delay, the execution of the third instruction 9th clock cycle instead of 8th clock cycle. So during the 8th clock cycle, no instruction will be executed in the 8th cycle. So if we will assume that we are having the 4 instruction in the program, say the 4 instructions or 5 instructions are there in the program, then what we were expecting? We were expecting that after each and every clock, this was our expectation under the ideal circumstances, under the no load condition, we are expecting that after the completion of the 5th machine cycle or 5th clock cycle, we will get the execution of one instruction after each clock cycle. But due to this delay, there will be no execution of any instruction in the 8th clock cycle. So the total time, the total execution time of the program will be increased by 1 clock cycle, and that will be the clock cycle consumed by the stall. So this is the impact of the structural hazard on the performance of the program. So this is the same problem and shown with the detailed data path. So here we are showing the detailed data path for the structural hazard, and again by considering the similar example, due to the access of single memory of the machine by 2 different instructions in the same stage. So again the same thing is there. Let's suppose this is the first instruction load, this is the instruction 1, instruction 2, instruction 3 and instruction 4, and with the assumption that only first instruction is going to load the data in its 4th cycle from the memory, rest are not going to do the same thing. And again the conflict will occur at the 4th stage, in which the first instruction load want to access the data for its instruction, and at the same time the instruction number 3 want to fetch the output from the memory. And as we have already assumed that only single memory unit is there, single memory is interfaced with the machine, so that is why 2 different instructions cannot access the data from the memory within the same cycle. So this is the structural hazard. This is a detailed diagram, and this particular diagram is providing the solution. So whatsoever the structural hazard caused pipeline, and that hazard will be removed by introducing what? Introducing one stall. So this is the one stall. Its another name is bubble. It can also be called as bubble. So whatsoever the conflict was there, that conflict was filled with bubble. So during this particular cycle, no new opcode will be fetched for the instruction 3. So the new opcode will be fetched in the 5th cycle instead of 4th cycle. So this delay of 1 clock cycle will be introduced within the one program. And again we have already discussed that otherwise we were expecting the output of the instruction 3 at clock cycle number 8, but due to this bubble, due to this stall, as the opcode was fetched with a 1 clock cycle delay, so that is why the output will also be available at the with 1 cycle delay, that is in 9th clock cycle. So we will not get any output at the clock cycle number 8. Okay, so this particular diagram is showing the detailed structure hazard with the detailed data path. Okay, and showing the solution for the structural hazard as well by introducing the stall, stall of 1 clock cycle. So next is now we will discuss what is the impact of the structural hazard on the performance of the pipeline structure. The first point is the structural hazard degrade the performance of the machine. That we have already discussed in the previous 2 slides. By introducing of the structural hazard, due to the conflict of the sharing of the resources, due to the conflict of the sharing of the common resources, the structural hazard delayed the execution of the program or increase the execution time of the program. Second is it also increases the CPI with the structural hazard. Under the normal circumstances, for no overhead, we are considering that the number of clock cycles required per instruction for pipeline structure, we are considering under the ideal condition is 1, but we have seen that the clock cycle per instruction will not be 1. More clock cycle will be added, and those number of clock cycle will depend upon the what is the length of the structural hazard. Okay, so by introducing the stalls and by introducing the bubbles, it degrades the performance of the structural hazard. This we have already discussed. If these are the disadvantages of the pipeline structure which is having the structural hazard, then why would a designer allow the structural hazard? So we will mention here 2 reasons. One is to reduce the cost and to reduce the latency of the unit. To make the unpipeline structure to the pipeline structure, all the functional units will have to be duplicate. Means we will have to do the duplicating of all the functional unit, and it may be too costly. For example, the machine that support both an instruction and a data cache memory access the every cycle required a high bandwidth, and to achieve that higher bandwidth, whatsoever the cost will have to be paid to introduce the double memory and the fast memory, that will increase the cost of the overall machine. So if the structural hazard, and it would not occur often and it is occurring only for the few instructions, then the cost of to save the cost of the overall structure will be more beneficial. And second is to reduce the latency. All the functional unit, to avoid the hazard, will introduce the too much latency from the registers. This is all about the structure hazard. Thank you.